Hey guys, what's up? You are about to view our multi-engine oral exam, and please feel free to leave any comments below. We are doing this for our first time. These are one-take deals, so there's probably errors, and we're always looking for your feedback on our videos. Thanks, and hope you enjoy the video.
Okay, so maintenance.
That's really loud, so you're gonna have to really talk over it.
Maintenance. You're going to start out, we have covered your maintenance items. You're going to have to pull out and show him, here's our new system. This shows that the annual is done. Point to it, the date. Here's the 100 hour. Here's the 100 hour compares with this. Do the math in front of them. That checks. Here's all of my, yeah, and they're getting updated. Charles says now they're getting updated. Transponder, static, ELT, it's all right there, shown. Here's the due dates, okay? And here's our ADs. We're gonna move into weight and balance. Now you see, it's been a long time since we've had to do a weight and balance. Dust off, things change. You know, you gotta know what changes and what doesn't. Okay, so then rolling into, I have my questions here. We're going to knock out some basics on the airplane. And I'm going to run through just some general specifications on the Seminole that you're going to do your Checkride in, right? So, with that being said, what is your maximum takeoff weight in the Seminole?
3,800.
Okay. What is your maximum flat extended speed in the Seminole?
Flat extended speed.
What speed can you extend your first notch of flaps?
I'm gonna go with 109.
Okay, it's 111.
111.
109. What's the significance of 109?
That's your traction, I believe.
Exactly.
Oh, yeah, that's right.
So, if you, like when we do an emergency descent, throw the landing gear down to give you drag and come down, and the max speed's 140. It makes you come down faster, right? But if you're doing 140 knots and you level off and we're still doing 140, you pull that gear up, what's going to happen? You're going too fast for the gear to come up.
Yeah.
So you have to be below 109. Okay, so with that being said, I'm going to go into V speeds and I'm just going to ask you and see where you're at. Normal rotation.
75.
Best angle.
82.
VXSE.
That's single engine, best angle, it's still 82.
Okay, good. Best rate?
Best rate is EY, so 88.
Good. Now this is much better. Just like that. But you see how I did that on purpose. I knew where the confusion could be with the 111, 109, and 140. And the reason I did that is because I want you to fully understand why there is. Now that I gave you the story, because I've done it before, you know, I was, even at 717, you need to come down, throw the gear down, come down like a bat out of hell. I leveled off, pulled the gear up, and it didn't come up. And I'm like, oh shit, I mean, slow below 235. And once you see that, then you're like, okay, now it makes sense. Continuing on V speeds, VSO.
Stall speed and the landing configuration.
With flaps.
With flaps, yeah.
Okay.
And then it's VMC 56, and then stall speed clean is 57.
Okay.
Yeah.
There's two speeds on your airspeed indicator. What are they?
Blue line and red line.
Red line.
Yeah.
What is red line? Define it for me.
Oh, it's maximum cruising speed.
That's what you answered. That's red line also. Maximum, don't go, but the other side of red line.
Stall speed.
Correct. What kind of
Yeah.
stall speed?
Single engine.
Correct.
Yeah.
What happens when you stall below red line?
You get into a spin.
What kind of spin? It's a VMC roll. That's why we do a VMC demo. Don't want to go there. Actually, I take that back. There's VMC minimum, so that's where you got that 56. I worded that incorrect. VSSE is one engine intentional speed of 82. So that red line is VMC You don't want to go below the red line VMC, or else you'll do a VMC will stall the airplane.
Yeah.
Okay? That's why when you're doing a VMC demo, he doesn't let you get below 65 or 70 because he doesn't want to really go into a VMC. So there's blue line, that is the single engine, going to give you the best rate of climb or the least rate of descent.
Yeah.
And then the red line, VMC, is minimum controllable airspeed with the critical engine and up. Below that, you're going to flip over. VSSE is stall speed single engine intentional.
Okay.
So there's really no significance to that VSSE, just know it's 82.
Okay.
So the red line is VMC, minimum controllable airspeed. Below that red line, you
Yeah.
lose control of the airplane. Red line is minimum controllable airspeed with critical engine and up. VSSE is the speed, single engine speed,
Simulated
intentional. Yeah.
single engine.
Okay.
So like, for instance, when you pretend like the engine's out during
Yeah.
a checkride, that's a
Okay.
simulated single engine out,
Or they
right?
put it far enough away from VMC so it gives you enough time to recover.
Yes.
Not be
Yeah,
scared.
it just says one engine intentional, 82. So let me try to work
But the
that
way
out.
I always
Okay.
memorize it was simulated single engine out.
Right.
That's VSSE, which is 82.
Well, yeah, you're not going to cut an
Red
engine
line,
below
what is red line?
VMC.
56?
Yeah.
Is it 56?
Yeah.
Red line is 56, which is VMC. Velocity minimum controllable airspeed is VMC, red line. If you
So-
have an engine out and you go below that, you're flipping over. You're VMC rolling. Because even VMC can change with weight, which gets us into something else.
That's why they
So
give you that
VMC is
82.
not always going to be 56 or whatever it is.
Yeah.
That's why they give you the VSSC. You're going to say you're an instructor and you're doing students and you're pulling engines in flight. You're never going to pull it below 82 knots.
Yeah.
Why?
Because VMC changes.
Yeah, it's 56. You might be at 60, but guess what? You know, where's your arm? You know,
Yeah.
is your arm, I mean, your CG, is your CG forward or aft? Is that going to raise or lower your VMC?
Right.
So it might be in that area and you don't want to roll over and find out.
Well, that's
But
when you get into smack cone.
yeah, so cutting the engine always above 82 keeps you safe. Okay, and then backing it up, VMC red line is where if you stall the engine, I mean the airplane with the critical engine in and up, you're going to go into a VMC roll. You explain it to me then, just to make sure you understand. What is the difference between VSSE? What is VSSE?
Simulated single engine,
Okay, and what is VMC?
red line.
And what does that mean? What is the definition of VMC?
It's a speed at which you don't go below a certain, that speed, otherwise you'll get into a VMC roll.
Okay,
Yeah. So
with the critical
56.
engine in up.
Critical
In this
engine up, yeah.
scenario, we don't have a critical engine, right?
Yeah.
What is your maximum abrupt control speed? VA, maximum abrupt. There's one at 2,700 pounds, which is the lower end,
Yeah.
and then there's one at the heavier full gross weight, which is what we
Yeah.
talked about. What's your full gross weight?
38.
Right.
Yeah.
And then you're here, see your zero fuel weight or whatever.
Yeah. I believe it's 112 to 135.
Very good. So 114 to 135, based on weight. You know, remember we used to talk about that in the private. We'd say maneuvering speed today is anywhere from 89 to 113 based on our weight. It's called 105, right in the middle.
I was going to ask you on that because I know we come back to 17 or 18, which gives us 100 knots for the rest of the check ride. Why don't you go between 114 and 135 since it's maneuvering speed?
Just the profiles are set up like that,
Okay.
you know, because you're in a faster airplane, so you just want to come with a number to always go to, you know, that keeps it somewhere right around there. Because you're always like, you're going to have to, when you do a VMC demo, right?
Yeah.
They want you to start it at 100, you know why? Because you're going to have to get down to 70 anyway.
Yeah.
So there's no reason to actually speed the airplane up to 120 and slow it back down and just do a VMC demo. So if you just do, with the exception of steep turns, everything at 100, it's just more
Yeah,
efficient.
because steep turns are going to do a 120, right?
Right.
Yeah.
That's the only thing that's not going to be starting at 100 knots.
Well, everything else is slow fly. These
Right.
are things that you go below that speed anyway,
Yeah.
maneuvering speed anyway.
So it's just efficient
Okay.
to keep it at 100. What is, you brought up the other red line. What is the red line we just discussed?
We discussed VMC,
All right, so what's the other speed, red line?
VNE,
Right, what's that?
I think it's 165, 163,
202.
202.
Then there is this is where you got it mixed up, maximum structural cruising speed. What is
That's
that?
162.
We're 169.
169.
So if you're tooling along and you're indicating 180 knots, and all of a sudden we start getting banged around, you're going to slow the plane down below 169, right? In smooth air, you can haul ass all the way up to 202,
Yeah.
okay? Good. What is the maximum flap extension speed?
Iffy. It was 111.
Yeah, exactly. So what is maximum gear extension speed?
Extension is 140.
Okay, what about extended?
109. Like retraction?
Oh, I said maximum. You said extension. We could throw it down anywhere up to 140, right? Can we fly around with the gear down at 140?
Yeah, but you don't want to rip it off right at 140.
So there is a speed on that. Maximum extended. There's extension and extended. It's
Two.
also 140.
Oh,
Okay, so extension, you can throw it down at 140. Sounds redundant, but when you get into different airplanes, they will be different numbers. They're the same here. You can fly around at 140. What is the maximum gear retraction speed?
109.
Right.
I have also another thing, in the event that there's landing gear failure and you want to drop the gear, what do you want to slow the plane to in order for the gear to drop?
100.
Yeah.
Yeah.
And where are you going to find that? If you forget,
Where in the POH
it's on your checklist.
or
POH also, but how about this? Manual gear extension, reduced airspeed below 100 knots. So before you do anything in the real world, if you throw the gear down and you're at glide slope intercept and you don't get it, first thing you're going to do, and this is where people screw this up. Who cares? Fly the plane. Hey, Tower 123 Tango Juliet, we need vectors. Give me heading and altitude. We got a gear problem. Stand by. I'll let you know. Go out there, fly around. They give you headings. Get your checklist out. Take your time. A lot of people just get so distracted. They're like, ugh, and they just crash for no reason. Eastern 401. Maybe she hasn't heard of it. There's a big L-1011 in 1972. Brand new airplane, 350 people on it, Eastern Airlines. Landing in Miami. Throw the gear down. One bulb doesn't come on, right? So they go around, they get vectors around, and nobody ends up flying the plane. Everybody gets so consumed with this light bulb that somehow somebody clicked the autopilot off by accident, and at the last minute they realized at 50 feet into the Everglades, like, what the f? They crashed. Go watch air disasters, it's this.
Yeah.
So basically, I'm telling you, if you get a gear problem, don't do anything. Just go, you know what, we need to break it off. I need vectors, clear traffic and terrain. I have a problem to work on. I'll let you know when I'm ready. And then they're going to come at you. And they're going to be like, how many people on board? How much fuel? And you have to say, stand by.
Yeah.
I can answer that stuff later.
Yeah.
Because it will distract the living shit out of you.
Yeah.
And you can easily just crash for no reason. So anyway, back to this.
And you rock your wings, right? Whenever you're trying to get it to come down. That's what Kevin said to do. You fly with a low approach by the tower. Or is my gear down? And you rock your wings.
It doesn't say that. You can do that
Yeah.
because, you can rock the wings and try to, what if it's just stuck? He's telling you experience stuff. But
Oh,
here, I just go by this. Manual gear extension. Reduce airspeed below 100. Okay. Lower landing gear lever. Pull emergency gear extension knob. You'll hear it go down.
yeah.
If electrical system's okay, verify green lights. And this airplane is where you'll get screwed. You'll have no green lights. Why? Because you have that nav lights on.
Yeah.
You remember that?
Mm-hmm.
That's the first thing I do. If I don't get the green lights, I'll reach over and go, oh shit, sure. Oh, there they are.
Yeah.
Leave emergency gear extension knob out. Then if you want, this is complete, then you can call tower and say, hey, I'm going to do a flyby. Can you see if my gear's down? And they'll say, okay, looks like your gear's down. Okay, bring me around for landing. If your gear's not down, then you can try to bring it down. That's,
Yeah.
I mean, so,
If anything, then you would just try to do soft field landing, right? Just land on the belly. You have to, the gear doesn't come down.
So you gotta get down somehow.
yeah, remember, these are good questions because nobody ever really trains you on this. What happens if you go through the whole thing and the gear does not come down?
Yeah.
Then I'll try to bring the gear out to land with no gear, you know?
Yeah.
So, and here's a couple things also. Okay, no landing gear. I've done my emergency procedure, still no landing gear. I have 2 out of 3. I think I'd rather just have none. So try to pull the gear back up. If the gear comes back up, okay, I'm gonna do a no gear landing. So just do a normal approach. And remember this, nobody tells you this, at the last minute when you know you've got it made, just reach over and pull your mixtures back and stop the engines. You know
Yeah.
why?
Rocks, right?
Yeah, you don't want to tear the engines up if you don't have to. Because if you land with the engines going, you're going to ruin the engine thing too.
Yeah.
So that's just experience, but this is good.
And at that point, you want to be going as slow as possible when you touch down.
Yeah.
And expect that when you put the flaps in, you're going to get the gear warning horn.
Yeah.
That's, I would probably do a no flap landing. Just, okay, so what's my next question? So remember, there's different speeds. There's the maximum gear extension, maximum gear extended, which they call it here gear operate, gear extended, either way. It never changes, it's 140.
Okay.
Pull it up, you have to be below 109. VLR, maximum gear retract speed. What is the maximum crosswind component in this airplane?
17.
Okay. So we've gone through pretty much all of those these speeds. And you have notes there. Tighter, memorize them more, be able to explain them. While we're talking about these speeds, have you ever heard of a service ceiling?
Yeah.
What is a service ceiling?
The service ceiling is the maximum amount of altitude that you can have on one engine, a single engine.
Service ceiling. I'd say single engine. This is why I brought you into this.
Oh,
There's
okay. There's
service
2,
ceiling,
yeah.
absolute ceiling. Then there's single engine service ceiling,
Yeah.
and single engine absolute ceiling.
Okay, yeah. This is when your airplane is only able to climb 100 feet per minute.
Okay.
Yeah. With the single engine, or, sorry.
With
or the
both
ceiling.
engines operating, yeah.
Yeah,
With both engines, right?
yeah. The single engine one is 50.
Very good.
Yeah.
Okay. What is the absolute ceiling?
It's when VX and VY are the same, and you will no longer be able to
Okay.
climb any farther.
All right, good.
And you're going to probably
Yeah.
experience what?
You
How do you know you got
drift
your-
down to the service ceiling.
Correct.
Yeah.
Yeah, very good. I just want to run through some basic systems. What size engines are on the airplane?
Lycom 0360. 181 horsepower.
How many cylinders?
4,
How many spark plugs?
8,
Where are they at?
4 on top, 4 on the bottom.
Okay. How much weight can you put in the baggage compartment?
200,
How much fuel does the airplane hold?
110.
Is that all usable?
No, 2 unusable.
Okay.
1 in each chamber.
All right. What happens if you lose an engine? I mean, both engines. What's your best glide speed?
Blue line, keep just blue line, 88 all the way down.
That's not a bad idea, I would say that, but actually it's not posted
I was
anywhere.
going to say, there's not a best glide
Right.
for a Seminole.
It's just between VX and VY,
Okay.
and 85 is a good number, which is blue line's 88, so
That's fine.
you don't have to worry about blue line because you don't have an engine anyway.
Okay.
Blue line is going to give you, with the critical engine and up, the best rate of climb with the least rate of descent. Remember when we were struggling for you to get around and we were doing, in the beginning of your training, you're like, why are we not climbing?
Oh, yeah.
Well, because you're at 105 knots at the pattern. I'm like, if you would pitch up the blue line, you're going to either get the least rate of descent or the best rate of climb. And even sometimes we went to blue line and we're still descending, and why was that?
You didn't have 0 thrust.
Well, not so much zero thrust. I give you zero thrust to simulate what you're doing, which is get rid of all the drag, which is mixture, prop, throttle, flaps up, gear up, identify, verify, dead foot, dead engine, idle, prop, mixture. That changes that dead engine out there. If you lose an engine, you have to get those props to go like this. Otherwise, it's like a big plate,
Yeah.
you know, creating drag. But if you get rid of that drag, that blue line, you're going to get a better. That's why it was so important to be efficient, not crazy, but mixture prop throttle, flaps up gear, identify, verify, dead foot, dead engine, left throttle, retard, left prop, feather, left mixture, cutoff, and then he'll give you 0 thrust. He's only doing that to simulate, to pretend you shut all that down, because he doesn't want to really shut it down.
Yeah.
Okay? There is a formula to figure out maneuvering speed. Do you happen to have any idea what that is for your actual, that exact day? You know, it's anywhere from, remember in the Archer I said 89 to 113, but we're just going to cut it in the middle.
Yeah.
Have you ever seen the formula? Believe it or not, you have this, you've just never looked below to the next thing. It's on the same chart as pressure, altitude, density, altitude, and then there's the third formula. Landing weight divided by maximum takeoff weight equals the square root multiplied by 131 gives you your actual maneuvering speed for the day. Why would any, and you can tell them that I have the formula, but I just cut it down the middle. I mean, I would say that in a freaking oral in a minute. I mean, if you want me to show you the exact, but it's not going to make a difference. That's why during the private I said anywhere from 89 to 113, put it in the middle, 105. Okay, so you know your stall speeds that we went through, the V speeds, are those constant
No, they change
with what?
with weight.
Okay, so what happens if Bevin doesn't do the trip with us today? What happens to our stall speeds?
They will decrease.
Okay, good.
Yeah.
What happens if Bevin doesn't go with us today? What happens to our maneuvering speed?
Decreases.
Okay.
This is less weight.
What happens to VMC?
It increases. Because with heavier weight,
She's getting out.
well, it would be better with heavier weight. VMC decreases with heavier weight because you have to create more lift.
Okay.
But by her getting out will increase VMC.
So, before we get into all the things that have affected, how do you come up with that number, VMC? How does the manufacturer come up with it?
They use the acronym COMBATS
Yeah.
to come up with it to keep it nice and equal on the
Okay.
playing field because obviously if they want to sell their aircraft to people that want to buy it, the lower the VMC, the more people that are going to want to buy it because you know it's farther away from the stall speed and less of a risk.
Sure.
So they want to create these conditions to where it keeps VMC steady and constant across the board and within safety regulations.
Who's they?
The FAA,
What about the manufacturer?
they don't care.
Right. So how come the manufacturer doesn't say, oh, VMC in your plane's 56, ours is 35?
Yeah.
Why do they not do that?
Because those regulations call us.
What are the regulations? So explain what combats is. I mean,
I can do it.
those are rules, right?
Yeah.
Set by who?
Well, I think they're regulated by the FAA.
These are conditions set by the FAA. The FAA
Okay.
interjects to every single company, Beechcraft, Piper, Cessna. I'm going to buy an airplane, right? And I want to have the most bang for my buck.
Yeah.
And I want to get, that airplane's cheaper and it's got a lower VMC. Why? Because Cessna says so, right?
Yeah.
But the FAA has to interject and say, you can't just come up with an erroneous low number.
Yeah.
I want you to do flight tests on this airplane based on
Those conditions.
these conditions,
Yeah.
okay? Because if you're going to buy an airplane, one of the biggest selling factors is you've got the best airplane with the lowest VMC, right? Because it's safer.
Yeah.
A lower VMC safer. You
Yeah.
agree?
Yeah.
So Beechcraft might sell an airplane and go, our airplane's $20,000 cheaper, but our VMC is 100 knots. And you're like, I don't want that airplane.
Yeah.
Okay? If
Yeah.
I'm going to build an airplane, the FAA says, you're going to test this airplane based on the most unfavorable CG, and then that's where the combats comes in.
Yeah.
What's combats?
I can draw it out.
Okay, draw it out for me.
Okay. So combats, the C in combats is critical engine and they want the the engine that's most adversely going to affect the performance of the aircraft to be in if it's
That's what is that?
the left engine.
So that's the critical engine.
Yeah.
You just define critical engine because somebody will say, what is the critical engine? And you'll say, that's the engine that will most adversely affect performance of the airplane. Okay.
In a conventional twin. The Seminole is not a conventional twin.
What is a conventional twin?
It's a twin engine that the propellers rotate in the same direction,
Which direction?
rotating to the right.
Okay.
Because our plane is
Correct. What is our call? Ours called?
just a constant speed.
When the two engines go like this, what are they doing?
Counter rotating.
Yes.
Okay.
Okay.
Yeah.
Conventional,
Mm-hmm.
counter-rotating.
Okay. The O is operating engine, maximum takeoff power, because you want more power, because more power will increase VMC, which makes it harder for them to make VMC lower. And then maximum takeoff weight, more weight equals more lift.
Wait a minute, don't answer, let him ask the questions.
Okay.
You're explaining what the guidelines are. The FAA says, here's what you have to have the airplane configured like to come up with VMC. If you can explain it to somebody, I don't care if you go home and explain it to your logbook, but explain it. The conditions to come up with VMC, because it comes down to people wanting to sell more airplanes.
Yeah.
I can sell more airplanes if I sell EB's aircraft multi-engine airplane for $5,000 compared to $200,000 for that Seminole, right?
Yeah.
And they're going to say, why is your airplane so cheap? And I'm like, well, because I just made it cheap. And they're like, well, what's VMC? Shit, I don't know. It's got to be over 150. Would my plane ever sell?
No.
If the FAA never interjected, it probably would. People would buy that thinking that, but the FAA is like, no. We need to make all these planes equally safe. So before anybody sells these planes, you're going to test fly it, and I want you to test fly it and tell me what VMC is based on. Your critical engine in-op, you're at max weight, maximum power on the operating engine, most aft CG.
Don't worry about explaining what everything means.
Right.
Just worry about what the regulations are.
Okay.
If he wants you to explain something like, well, what is an AFCG? Then you need to be prepared to explain.
Right.
Don't just hand out the information.
Why is the left engine on a conventional twin the critical engine?
Because it most adversely affects the performance
Correct.
of the aircraft.
And so, how do they determine what, there's an acronym. How do they determine what determines that critical engine? What are the factors? There's a bunch of them that determine and make that thing the critical engine. That makes it most adversely affects the performance of the airplane. Do you know what those are? There's some things.
Yeah. It's not, no, it's not passed though because
Sure.
it's.
Why is it not passed?
Because those are just the left turning tendencies.
What-
Not the critical
What's
engine.
passed?
Peak factor, accelerated slipstream.
Okay, explain how
slide,
passed affects it.
Because in P factor, want me to go into P factor or the?
Yeah, passed.
Okay.
Okay, here's the question. I'm trying to ask it without giving away.
Because I know like the arm.
Why is the
is
left
different.
critical engine on a conventional, why is the left engine the critical engine on a conventional twin? Why is that? Conventional twin,
Because the arm is further away.
Yeah.
well, there's passed. And you're right. Each one of them affects the arm, right? So you got to explain P factor. What does that do? And how does that affect the arm? And then you have to get into accelerated slipstream. And why is that? Make that critical
Yeah, right.
engine. And what does that do to the arm? And
Yeah.
are you familiar with this? Can you really explain it? Go for it. Why on a conventional twin is the left engine the critical engine?
So this is P factor. So P factor is when it's at a higher angle of attack, and the blade angle is taking a bigger bite of air going downward, and it's creating a left turning tendency, it's creating like a bigger bite of, taking a bigger bite of air on the descending blade versus the ascending blade. So it's creating more thrust going outward like that.
Okay.
And that's in a conventional twin, this arm is shorter and this arm is longer.
Okay, that's what I was
So
getting at. Good.
it's gonna have more of a force to turn to the left because same like a door handle. If you push here, it's gonna be harder to open up the door versus if you pushed here, you have more force because there's more distance between the hinge and the knob.
I like that. Where'd you get that?
Video on YouTube.
Good for you. Perfect. Okay. So continue. What's the next one?
Accelerated slipstream. Is when your propellers are spinning, but there's more lift being created on the inside part. Let's say this is operating, but on the inside part versus the outer part. So it's going to want to create more lift on the inner part of the wing versus the outer part of the wing. So on a conventional twin, the left engine is, but the right engine is going to create a more left turning tendency because there's more lift being produced over here versus over here. And it's going to create kind of like a horizontal component going this way versus going this way, straight out.
Okay. I can understand that. And there's, with the right engine creating more lift, is there a reason for that? Is there something with that air going back, that it's helping?
Yeah, because the rudder is becoming
Exactly.
more effective because it's controlled
Awesome.
by that. Spiraling slipstream. The air is just basically coming through the prop and it's kind of going like this. So on the left engine, it'll be in contact with the rudder and it's going to want to make it turn more to the left.
Okay. I like that. The other one, what's the other one doing? It's just,
What?
no, the right engine. As you see your squiggly thing.
Oh, it's just going
Yeah,
off.
it's not doing shit. You're not
Yeah.
getting anything. Okay.
Torque is equal and opposite reaction, like the turn of the crankshaft. So on like a crankshaft, it's turning this way. So with every action, there's an equal opposite reaction. So it's going to want to turn more to the left, based on the way, just the way the propeller's moving.
You got that arrow. This little arrow. What's that little arrow?
It's just the crankshaft.
Which way is that
To the left.
crankshaft turning?
And a conventional twin,
Okay, yeah, conventional twin. Is that what
Yeah.
we're talking about?
Yeah.
Which way is it turning?
to the left,
To the left?
or to the right, actually. Okay.
Because you said torque.
Equal and opposite.
Yeah. If you want an example of that, you ever seen the airplanes that you just wind up on a rubber band, the prop?
Mm-hmm.
Well, if you do that, and if I'm going to go like this, see, if I just hold that prop and let the body go, which way is it going to turn?
Opposite.
Opposite.
Yeah.
That's torque. So you understand what that is? Past. What is past? That acronym. Don't go through all of you just did, but what is that?
The way that they create, identifying the critical engine in a conventional twin.
Okay.
When we go below VOC, why do we lose directional control?
On
Because the rudder is no longer effective. It cannot
Okay.
overcome asymmetrical thrust.
That is correct. There's some basic things that you can throw in there. Power, drag, weight. But these are all things that affect VOC, so that's what we're going to kind of get into. I'm going to ask that question. It says, why do we lose directional control? List some reasons. Airspeed, low. Power, not enough. Drag, we've got a shit ton of drag out there. And weight, we got a lower high weight based on our conditions for that day. Again, what is blue line and how do we define it using single engine?
The best rate of climb that you can get.
Or it gives you one of two things.
Best rate
Of climb,
of climb, yeah. And,
or think about your single engine surface ceiling, right?
okay.
You're at blue line and you're getting 50 feet per minute. That's the best rate of climb you're going to get. And as you're climbing, what are you going to hit?
The absolute surface.
And that's going to give you what? The
Descent.
least amount of descent.
Oh, least amount of descent. Okay.
So The blue line is going to give you one of two things. Best rate of climb or the least amount of descent. Descent, you're going to descend down till you hit an area where you can get some, at least level off, right? Going to get into some factors that affect VMC. First of all, can you give me some reasons? Is VMC a solid number?
No,
It doesn't move around a little bit?
it does.
Why?
Because of weight,
You
atmospheric
said weight.
conditions.
What happens with weight? If we kick her out and go to Tampa,
Yeah,
we just got lighter.
yeah. VNC will increase
Okay.
because it has less component of lift as we decrease the weight.
Okay. We see our CG here. Where's our, let's use Bevin's takeoff weight? Right there. Is that a forward or aft CG?
Forward.
Okay. So with a more forward CG, what happens to VMC?
It decreases
Okay, why is that?
because the arm is closer to the arm, so the rudder is more effective
Correct.
when the CG is forward
Why is that?
because it's closer on the arm
Closer
or
or?
no farther away.
Yeah.
Yeah.
Okay.
Yeah.
Here, we get to Tampa. What happened to our CG?
It moved a little bit more forward.
It
Yeah.
did. Yeah. Okay, good. What happens if that CG moved further aft? What happened to your VMC?
It increases so does our performance though,
All right, why?
because it's on the shorter arm of the arm.
And what does that do to your rudder?
Less effective.
Correct.
Yeah.
Okay, so I'm going to run through some stuff. What happens to VMC with a power increase?
It increases VMC because
Why?
there's more thrust,
Okay.
more power.
All right. What about temperature increase?
Are you tying that into density altitude or is it just temperature?
Just temperature. Density, altitude is another thing, but temperature.
Yeah.
It's hot as shit today. What
Yeah.
happens to VMC?
As temperature increases,
Temperature increases. So, okay, you said this. As you have more power, what happens to VMC?
it increases.
All right. So on a hot ass day, and you put the power for it, are you going to have more power?
I see, yeah, okay, yeah, no.
So as temperature increases, what happens?
VMC goes down
Yes. Why?
because there's less power input to
Correct,
the
yeah.
engine.
There's less dense. Okay, now, how about density altitude is increasing? What happens to VMC?
Density altitude, so the air is thicker.
Density altitude is increasing. Is that a good thing or a bad thing?
It's a good thing. No.
As density altitude increases out here, your plane, this goes back to your private stuff, your plane, remember we were talking about it feels like pressure altitude, and so also density altitude. But when you're sitting on the ground, the plane is already feeling like it's at 1,800 feet,
Okay.
right?
Yeah.
So it's going to be shittier reaction.
Mhm.
So as density altitude,
Increases, VMC decreases.
why?
Because it's gonna have less horsepower.
Correct.
Less performance, okay.
For both of those, the air's shittier, it's less dense.
Okay.
Okay. So what about pressure?
Pressure,
Altitude, pressure, and pressure decrease, like 30, 12, drops down to say 2,999. What happens to VMC?
decrease.
Correct.
Yeah.
Why?
Because there's less engine power needed.
Exactly.
Yeah,
All of those are the
thing.
same. Yeah.
Yeah, okay.
Let's get into when you lose an engine, and if you don't do anything,
So you don't feather it.
right? You don't
Yeah.
like you're at 0 degrees. I mean, there's no banking into the good engine. You don't do shit.
Yeah,
What happens to VMC?
it increases.
Okay.
Yeah,
Why?
because in the bank, you're taking out that side slip if you don't have a bank, you don't have 0 side slip, so you have that left turning tendency,
Yeah.
and it's making the engine run harder, so there's more power,
Well, if you don't do anything, what is actually happening?
more drag too.
Yeah, and is your rudder effective? Not effective? What?
No, it's
Okay.
not effective.
Correct. So if you don't do anything, your rudder is less effective. So it's going to increase VMC, right?
Yeah.
So then let's say you go 2 to 3 degrees of bank. Then you get engine. What's going on there?
Decreases VMC.
Right? And then what happens if you go to the perfect setting of 5 degrees of bank?
It'll increase because that's too much. Too much of a bank.
No.
Actually, more bank
Is
decreases VMC because you're going to have more control of the aircraft.
so
The
zero,
rudder is going to get more air.
0 raises,
Okay.
2 to 3 middle of the road, 5 degrees lowers. So that's perfect. What happens if you don't do anything and your prop is windowing out there and you don't shut down? What's happening to VMC?
It's increasing because
Okay.
there's more drag.
So what would you? How can you decrease VMC with that scenario?
Feather.
Correct, feather. What happens to VMC if you have your flaps extended?
It creates more lift, so therefore VMC increases.
Flaps down, VMC will decrease.
Why is that? Isn't it, don't you use flaps to
More
increase?
induced drag from good engine side prevents yaw towards the dead engine. It's on that chart, that this chart that I'm looking at here. Gear down, what happens to VMC?
It lowers it because the keel.
Depends.
If the CG is.
Yeah, it depends on where it is. So I'd put a big question mark and go. Depends on where your CG is. Yeah, it moves the CG. You're right, keel VMC goes down dash fuel effect. What happens to your VMC if your critical engine fails? Does it go up or down?
The critical engine fails. It'll increase because you
Very
want
good.
the critical engine to be operating.
Awesome,
Yeah.
yeah. This is really getting deep here, but as you are landing, you get into ground effect.
Oh, I know this.
Do you?
Yeah.
Good.
Ground
What
effect.
happens to your, does VMC go up or down?
It goes down. Because you're in ground effect, so it takes out that excess yaw and is it
In ground effect, VMC goes up with less drag. But it doesn't matter, you're landing anyways.
because why again?
You're losing drag
Losing drag.
because you're slowing down, that induced drag is going down, so you're losing drag, your VMC is going up. Okay, so we said temperature, pressure, density, altitude. As they all increase, VMC goes down because the air is less dense. But what happens to your power? Does it go up or down with all of those?
With everything increasing,
With your, if you got a high temperature, density, altitude, or high pressure, or
your power decreases.
correct. Okay. When we did the 0, middle of the road, and up to 5 degrees, what happens to your performance as you do each of those? You're at 0, middle of the road, and then up to 5 degrees.
You want me to explain it, everyone? So 0.
What happens to your performance if you lose your engine and you have a 0 degree bank, no turn?
Your performance goes down.
Okay, good.
Yeah.
Now, what about you're starting at 2 to 3 degrees? What happens to your performance?
That'd be considered just middle of the road.
Yeah.
So,
Yeah.
and then the 5 would be better for performance.
Right. This says here, when you're going 2 to 3, your performance is actually increasing. And then when you get to 5 degrees, your performance is decreasing because you have more drag, more slip. Okay, feather propeller, does that increase or decrease VMC?
Feather propeller
Yeah.
decreases because there's less drag.
What does that do for performance? Does that increase or decrease performance?
I would say it increases.
Very good.
because
Just use your head. Okay. Aft CG, you said gives you a higher.
VMC.
Does that increase or decrease performance?
It increases performance.
That's why.
Because the rudder is more effective.
Less down tail force required, less induced drag. What happens to your performance with a heavier airplane?
A heavier airplane performance goes down,
Yeah.
but VMC will increase on that. No, lower. Sorry.
I was going to say you just undid what you said. Wow.
I know.
Remember, don't give things up. Critical engine fails. What happens to performance? Does it go up or down?
Go down because your critical engine's the most one that most.
You want to get real
increasing.
deep, it's because you have more air side drag.
Uh,
In ground effect, what happens to your performance?
would go down because you're losing.
It's gonna go up because you're have less drag. How are you gonna recover if you get into a VMC roll?
You want to put the throttles to idle,
Right.
pitch down or pitch for blue line.
Right.
You want to leave your operating engine still operating, right? Unless you want to cut off.
Well,
the
if you go
mixture.
throttle idle, what you're doing, you're getting rid of that rolling tendency. That's why you're going throttle
Well, the
idle.
rudder's already there, so you can't slam the rudder.
Sure you can. If you're in a spin,
Yeah.
you're gonna go opposite rudder.
Same way you would recover from a normal spin.
Yeah.
Okay.
So
Power, you can use paired power idle, air arms neutral,
yeah,
rudder,
opposite rudder, and then if you get out of it, then try to come back and then pitch for speed and get above red line and add power again. How many fuel pumps do you have per engine?
2, and 4 altogether.
Right. What are they? There are 2 different types of fuel pumps.
Oh, 2 electrically driven and 2 engine driven.
So what? 2 engine driven and 2 electric. Not electrically. Well, it could be electrically driven. There's the electric fuel pumps. Yeah. So when you're cross feeding, can you explain how that works?
Yeah, you want to suck off the big tit.
That's what I said.
So.
Tell him that. See, tell him. Tom told me, suck off the big tit.
Yeah. Yeah.
Are you transferring fuel? You know, say you got the right side shut down
But you want to suck off.
and you're running out of gas on the left
Mhm.
and you need to get to that gas on the right. So how are you going to do that?
So the left one is operating, you're saying, but the right is
Mhm.
shut down. So left, you're going to turn everything on, and you're going to put cross feed on the left, everything off on the right, and the fuel's going to go from the tank to the engine.
Okay, so is there any, it's not going into the tank? Okay. Are there any cross feed limitations?
Yeah, you don't want to cross feed and take off or landing.
Okay.
Or
Yeah.
taxi.
Okay. Taxi, takeoff, landing.
Taxi takeoff.
Without you looking at it, what would you do with engine fire during start?
During start,
Yeah.
mixture cut off, valve flaps open, throttle idle.
During
And
start.
during start, your throttle is idle.
During start, you're like,
I would continue to
Yes.
try to start it and see if it would suck the fire
Yeah.
back in and extinguish itself. If not, then get a mixture cut off and get the hell out of there.
and grab a fire
And
extinguisher.
grab a
if you-
fire extinguisher.
Okay. So if you're cranking and you see a fire, keep cranking to suck that
Okay.
flame out.
Okay.
If you
Get
stop
too
and
bad.
a fire started, get out of the plane, and if you can, get a fire extinguisher on.
Make sure you turn off your fuel selector and cut your mixture
Yeah.
before you get out of the
Okay.
plane. And even if it starts and the flame fire goes out, then you can shut everything down. You're not going to be like, okay, that worked.
Yeah.
And keep going.
So, start a fire, drain the crank, keep cranking. Okay, fire goes out, engine starts,
Then
shut it down.
Okay.
Okay. Cranking, fire. Does not go out, stop cranking, mixture, cut off, fire, keep going, fight the fire. What are we doing different at 500 feet when we lose an engine that we're doing different at 5,000 feet when you do an engine shutdown?
You're not worrying about your fuel pumps, all that kind of stuff. You're just
Exactly.
feathering the prop
You're
and
quicker. Mixture, prop, throttle, flaps up, gear, identify, verify, dead
Yeah.
foot, dead engine, idle, feather, mixture. No
Yeah.
time for a checklist, come back and land. 5,000 feet, okay, no problem. Let me get this checklist out. Okay, it's not as quick. You know, you review the checklist, put it down, then you do all your items, boom, 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 boom. But there's also a difference between going too fast, but not fast enough. And we've seen both ends of the spectrum. haven't we?
yeah.
Can you explain the landing gear system? How does it work?
Yes, I can draw it out for you.
Draw it up.
There's a hydraulic reservoir right here, and a fuel pump here, and these are intake lines, and There are return lines too. There's a bleed hole over here to relieve pressure on the low side. And there's a thermal relief valve over here to relieve pressure on the high pressure side. So it's gonna come down. There's a Piper mounting base right here, and it's gonna come down into 2 chambers. This is the high pressure side, this is the low pressure side, and we'll have your 3 cylinders with the landing gear in here.
Are those the gears?
Yeah.
Okay, good.
Yeah. And the high pressure is going to retract the gear, so it's going to go to the opposite side of the cylinder, so it's going to go to the bottom because the fluid is going to fill it up here and it's going to force the gear to come up.
Okay.
So that, and then the low pressure, you want to lower the gear, so it's going to go to the top of the cylinders. There's emergency gear extend. I'll just put it in here. It'll equalize the pressure between the 2 of them to force the gear down.
Okay. What's holding the gear up?
Hydraulic pressure.
Okay.
Yeah. Oh,
Is that the
this
same
is-
hydraulic pressure
this
as
is-
used in your brake line?
No, the brakes and the landing gear are 2 independent hydraulic systems.
Oh, okay, cool.
There's a down limit switch. Oh, that's what I was forgetting. I think it's above the Piper mounting base. There's a shuttle valve that looks like this. It'll have, but it like moves back and forth, and it'll allow the hydraulic fluid to come through the landing gear, go to the high pressure side to raise the gear, or it will come through the low pressure side and have it lower the gear.
How many fuel vents do we have?
Fuel vents, 2
Is there 2?
in the tops of the caps.
Okay, so the
Yeah.
fuel, are you telling me the fuel caps are vented?
Yes.
Good. Okay. Do we have an accumulator, an unfeathering accumulator?
Yes.
We have an accumulator?
It's
Or no, that-
controlled. It's just a separate chamber in the
Okay.
prop system.
Because there's older models that have,
We don't have.
no, we have the younger model.
Yeah.
You might get to the older model where I think they have a nitrogen system that'll
Yeah.
bang it, you know.
That's what he explains in the prop system.
Okay. So what kind do we have? We don't, that's why, you can tell we don't have the nitrogen system to
No, that's why we have to
offload the
it.
airplane. To
To
get some air
unfeather.
going through there,
So
yeah.
we don't have that kickstart, 'cause
Right.
that's what it does.
Exactly.
Okay.
Good kickstart. You can use
Yeah.
that. Kickstart it out of feather.
Yeah.
We have to actually unload the airplane and descend it to get it to unfeather. Okay. So then, also with that being said, how come when we land and we go to idle, the airplane, the props, you know, we're below 950 RPM, right? Isn't that where the plane will go into feather below 950?
It won't.
All right, when we're feathering in flight, at what RPM do those props feather?
Above 950.
Above? It's below 950. You're going all the way back to
On the
idle.
ground, when you're idle on the ground, they don't feather because there's a squat switch
Yeah.
that prevents it from doing that.
Yeah.
Because if it feathered on the ground, then you would have issues starting it up.
Yeah.
So you're saying above. We're shutting an engine down, so we want to bring the power down, right?
Oh, okay.
Remember when we're on the ground? We're at
So
1,000.
only feathers below 950.
Correct.
Okay.
In flight. And she's saying it won't do it on the ground because of a squat switch preventing that from happening. And what does it do? It keeps something in position to allow it not to feather.
The centrifugal stop pins.
Correct. Oh, is this thing carbureted or fuel injected?
Carbureted.
Okay.
I know how to draw out the carburetor too if you ask me questions.
All right. That's it. You've got your areas. Study weight and balance. Study more combats. Study relative wind to the chord line because the greater angle of attack gives you more rudder effectiveness. Okay. That's just a few pages past. I sent you the picture. Other than that, I think you're going to be pretty good on the oral. What do you think?